All right, everybody. Thanks for being here. Is another Fluence community call, and actually, it's going to be a really good one. We have a lot going on today. We have tech teams update from the core team, and then we have community developer presentation from one of the previous hackathons. Very cool. And then we got a couple of educational talks from the core dev team, including Marine JS and how to run WebAssembly on JS Peer, which is super cool. That's been making a long time, and more on Registry. Dmitry, take it away.
I will. What do you want?
Yes. Did we forget to start broadcasting to YouTube? We usually do start broadcasts. No?
We usually do. However, I think Anna is doing it right now.
Okay. So sorry for interrupting you.
So speaking about the updates, we are focused on stabilization over the last month since the last community call. So we have actually a lot of changes. We will make a lot of releases tomorrow. We decided to shift it one day to have just more time for the team to prepare for the talks. But the main updates will come from Pavel, Valery, and Alexey later during the call. So let's just proceed.
Okay, well, I want to welcome Matt and Bob. They were participants at the Gitcoin shelling hackathon. And they are very unique in the sense that they are brand new to Web3 and basically learn by doing the accelerated way, entering hackathons. So guys, take it away.
Hey, thanks for having us here today. My name is Bob. It's my friend Matt. We've been working together doing software for about 20 years. And we've been doing software engineering professionally, each for about 30 years. We both started off, our first experience with the internet was Web 1, which was all about democratization of information. So it was a very pro-social approach to the internet. It was very idealistic, and that was what got us excited about it. Then, of course, Web 2 came along, and we spent a few years turning rich people even richer and making a little bit of money ourselves, but it wasn't nearly as satisfying. Well, a few months ago, I read an article on Andreessen Horowitz that was about DAOs and how they're bringing gig economy and decentralization back to the internet in Web3, and that was really exciting to me. And literally about 2 weeks later, I put in my resignation at Amazon, and about a week and a half after that, we were working on the Shelling Point hackathon. So it's been a whirlwind tour. We're really enjoying ourselves. We're building up a company that's going to do data engineering and data science pipelines in a decentralized fashion. And so I'd like to turn it over to Matt for a minute to talk about the data engineering side.
Greetings. So what I love about data engineering is it's a new puzzle every single day. So it's like taking massive amounts of data and picking out little tiny bits that are pertinent to our current objective. It's better than finding a needle in a haystack, because in a needle in a haystack, you have all these unrelated straw pieces. You know, there's no relationship within. In the data world, we can selectively find data that is related roughly towards the objective we're shooting for, pick through massive amounts of data. Let's take an example, like GitHub. There's 200+ million different repositories in GitHub, contributed by 70 million different users. That's a lot of stuff. Can't go through it very quickly. But if we look through it and find out specific items within there, we can sort through and find out a lot of information. For example, looking through commits. In the commit logs, you can see what files they've put in, what types of files, what the programming languages, how many lines of code, libraries, all sorts of things that we can find from that. So I can sort through very quickly and find little bits and pieces and feed it into one consolidated block of data. So from that, Here's one thing where Fluence can play a part. We can divide and conquer these vast amounts of data across different nodes, have them sort through the data. It's very data intensive, but it's not terribly CPU intensive. So we can feed through large amounts of data, find little bits and pieces and put them back together. So once we've got all this data put together, now we can feed it to the real magic layer, which is where we do machine learning and data science. And Bob here knows a lot more about that. So let me hand it back to you.
So yeah, it's really nice creating the whole pipeline and having both sides working together. So the data engineering that Matt does creates this really dense, highly concentrated data that works really nicely in machine learning models, which we can then apply to try to find software engineers who are similar to each other, find software engineers that are particularly capable, their skills are particularly applicable to an individual project. And the goal there really is to make it easier for Web3 hackers to jump from project to project, to explore new directions with their careers, to have a little bit more freedom in what they do with their time, less of the kind of golden handcuffs that we see working for giant corporations in Web2. So we want to try to make that a little bit more standard way of doing things, and not have to be beholden to the big corporations. And again, doing the data science side, it's really nice doing that stuff on Fluence. You guys are using Marine, which is a nice are using Rust, which is a nice high performance language, putting it into wasm modules, which are really high performance, but can run on any platform. You don't need specialized hardware. I think there's a really good opportunity for us to deploy this code out. You can spin up lots of nodes very quickly when you need a lot of compute all at once, and then drop them back down so that you're not paying for them when you're not using them. It's a really nice combination. Doing data engineering and data science on the Fluence platform, I think, is going to be really exciting for us. I want to thank you for building out the platform, and I'm looking forward to finding out what we can do with you in the future.
Definitely. Thank you.
Very cool. Does anybody have any questions? I do. So it was not very long ago when you partook in the hackathon. Basically, new to Rust, new to Fluence, new to React, if I remember. I mean, new to everything. Yes. I think the Google sign-up form was probably the only thing you recognized when you entered the hackathon, which is great. And now you're basically working on building distributed, decentralized data pipelines. And I'm just personally interested. You accelerated your growth in this space very, very quickly. And I was just sort of wondering, how you got there, how you got from the custodial wallet to working on distributed, decentralized data pipelines, which is something we're super interested in, by the way.
Sure. Well, two big parts of it. One is, we've been doing this for a long time. I'm already a data engineering, data science specialist. Matt's been doing a lot of data work, and so switching to data engineering was very easy for him.
Lots of integration processing, but yeah, so they're very similar logic.
Yeah. So the work itself wasn't new to us. It was just the languages, and we've been learning new languages for 30 years. So learning another new language isn't that big a deal. The idea that the process flow, the decentralized process flow that Fluence does, was really the biggest learning experience for us. And honestly, at first, when I first looked at it, I didn't get it. I wasn't totally convinced. But then I started looking through the language for distributing the sections of processing, and it started to make a lot of sense to me. And so we were just going to do a hackathon to just kind of start exploring the space, but it turned out we really like what you're doing, and we're going to try to integrate it into our long-term vision of doing data engineering and data science pipelines.
Yeah, this is great. And as I said, we're super interested in data pipelines, and I think a couple of the announcements that are coming up right after are very, very pertinent to what you're doing, and definitely want to obviously stay in touch with you and support you in your journey there. If nobody else has any questions, we can, I don't know, who's first? Pavel, Valery, Alexei, I'm looking at you, Alexei, like you're right smack in the middle for me, so I'm looking at you. You good to go?
Yeah, I think yes.
All right, let's do it.
So I want to present your latest registry updates, which we performed last week. About registry, it's essential part of Fluence protocol, which allows us to find in runtime services and resources. And by the way, you know, if you don't know, this part of code which uses registry as it is. So we published registry a month ago, and for this month and internal testing, we find some problems and we fix bugs and all this stuff. And what's changed? On this previous presentation, where was routing terminology, like we have a route and register providers for this route, but it's not so clearly, not so clear, and with it comes a lot of misunderstanding. So we decided to move our API in terminology to resource API. So anyone can register resource and register for as a provider for this resource. It's is better described in the documentation. You can look up to it. Besides the update of terminology, we fixed all the bugs and make code more stable. Also, we improved error handling, and every call return stream of the errors, and you can easily debug now all your flow with registry. So latest version for latest stable version for Node registry, Fluence JS and Aqua on the slide. Please update it if you want to use registry in a stable condition. And thank you, and check out our documentation in Aqua book for this stuff, and try out our examples. I think that's all. If you have any questions.
Questions? Anybody? Questions? Going once, going twice. All right, I have one then. For those who weren't on the last call, what's sort of your basic example or use case for the registry, just so that people have context?
Basic use case. So if you wanna find in runtime group of services grouped by some principle, or you want to find some cluster of peers, so you can register a resource with your custom label and find in runtime services or peers, and that's all.
Well, that's enough. That's pretty damn cool. All right.
Provide some more examples. Alexey, could you get to the slide with the code, like send everyone? No, the next one. Here we have a snippet to create a resource which is connected to the peer ID which you're being using with the Fluence JS. So basically, if you know the peer ID, you can take an arbitrary string and check if this peer provides this kind of resource. For example, imagine that you have a user, and this user has many devices, like the phone, the notebook, I don't know what, and wants to get some updates from the network, like in a messaging application, for example. you can assume that there is some label for the resource, and you can try to find all the routes, all the providers of this resource. And in this case, the resource itself is just the presence that this client device is being connected to the network, and you can find the route to this device. This is one use case. Another use case is when you, for example, want to deploy some data holding service to the network, and then you want to find this service after you, I don't know, rebooted your computer, or find the resource for another peer. Like if you create your, I don't know, avatar service or just avatar, you can register the providers like Fluence nodes with IPFS services with this avatar image, for example, to the registry, and then find it, resolve, get the image. Another example. The third example is building clusters in the network, like replica sets, for example, or something like that, or doing even load balancing in some cases. In this case, you treat the resource as the cluster ID, or the whole cluster is the resource. The resource ID identifies this distributed resource, and you can find that all the providers can find each other using this mechanism, and you can find which peers are currently online and serving this cluster, for example. So having these three examples in mind, Registry provides like a lot of capabilities for building decentralized protocols on top of Fluence.
All right. There we have it. Okay, anybody have any questions? No, all right. I've done my question. So who's next? Valery?
I think me, yeah. I think I'm next.
Go for it. It's all yours.
Yeah. So I need to share the data. Yeah, that was good. Do you see it? The presentation, or no?
Yes, we do.
Yes, we do.
Yeah. So I will present the Marine.js milestone 2 as we are going through this story. In this milestone, we will support the arbitrary single module services in Fluence JS. Not arbitrary, but with like pure models, not without WASM. So let me remind you how the Fluence network is organized. We have Fluence nodes. Where is my cursor? Okay, we have Fluence nodes. We have browser nodes, and we have services in the Fluence node running on the Fluence nodes that connect the network to some outer things like Ethereum, IPFS, or whatever. And we actually can run some services on Fluence JS peer too, and we may need to run them, but we have some problems when we trying to do it. We previously we could write only JavaScript services for Fluence JS, or we could wrap a Marine service into bindgen, wasm bindgen for us, and compile it with bindgen, make a JavaScript wrapper, and pass it to Fluence JS to run it. So it's painful. And if you don't have some service that needs private data or something, then the only way to use it from browser is to pass this private data to the relay. And it is not good, obviously. So we need to somehow also there is no way that I know that allows us to dynamically load a wasm module on browser peer, like write a function in aqua that just loads the code and that browser peer can execute. So we need to solve this problem somehow. And our way is to create a Marine runtime for JS to support the same services that are on our Rust node, on our browser node. So we will be able to do everything that we are able to do with the Rust node, with browser node. So that sounds super cool. It unlocks many options for people, and that's cool. So let's look on how Marine works. It uses wasm. It runs this code once in wasm. It uses interface types to have a good interface, like to have ability to pass structs inside wasm and receive structs from wasm, strings, arrays, or whatever. And also it provides binaries, interface for binaries, like you can have a wrapper for a CURL function and that Marine will create for you and provided for the wasm, so you can call the binary host system from your wasm. So, and it is good for using as part of the some software like Rust node, which uses Marine to run services. Let us talk about some more about interface types. What's it? Wasm has only 4 basic types, like int divine, int 32, int 64, float, and it's not super useful to have interfaces like this. How could you pass a string? Pass just bytes, it's not good. So interface types proposal provides an adapter for the module experts, a way to how to interpret the arguments of simple types as arguments of complex types like strings, structures, and so on. And we have our implementation of these interface types proposal. So let's go next for our approach to implement Marine on JavaScript. So we could just rewrite Marine and use it on JavaScript, like rewrite it fully on JavaScript. Or we could reuse code and compile Marine to WebAssembly and just make some some interfaces for wasm to call JavaScript stuff and provide interface from wasm to be used from JavaScript. So we decided to reuse code. We think that it is simpler to, it's faster to implement, and we could improve performance in future. And so there was a problem. We couldn't run wasm in wasmer in a browser. So we should use browser native WebAssembly runtime, which is accessible from JavaScript WebAssembly module. So that is super high level interface that Fluence JS provides for users. So you as user Fluence JS can actually use it. So we have function register and remove Marine service. They are called from aqua, so we don't have any interface for call. So what we have here, the register function takes wasm bytes, just bytes, and service ID, and that's all. Don't need anything more. And remove service can remove service just by its ID. It's super simple. The ID is the service ID that Aqua uses to identify the service. So let's go deeper. The Fluence JS inside has the copy of wasm the copy of interface used in Rust. It's called Fluence AppService. It can be initialized. It can create service, terminate everything, and it can call service. So to call service, we need to know its service ID. We need to know a function name, and we need arguments as a string, and call parameters, which we won't discuss here, and have a result. So pretty simple. And the super low-level interface, that is interface of the marine of that WebAssembly that does all the stuff with interface types and so on. It needs wasm instance, instantiated wasm module, bytes that stored in the wasm wasm that represent the interface type adapter that show how to work with this wasm, and just the name. And also we are able to call this module by its name. We need just module name, function name, and arguments in JSON form. So we also have an example of how it looks like, how to use the Marine.js inside. We can have a Rust service that have some structs, have some function that gets arguments, returns some values. So, and how we call it in using Marine.js, we just provide module name, service function, build JSON that represents the arguments, and get the result, check the error if needed, or just check the result if we're sure that it will not fail. What's interesting that it's not about that stupid deserialization from JSON. The Marine actually checks types, checks if the function, if the types match the function signature, and return meaningful errors for everything. And what is also good, that as we have only JSON string, we can dynamically decide what service with what arguments we need to call what function. It unlocks many options for the Fluence JS implementation. So next is the diagram of how the call works. So Fluence JS receives a request to call a service from Aqua. Then it dispatches the service to Fluence AppService, which finds the service by its ID, calls the module in Marine.js. Marine.js passes the args to the interface types to check the signature and the stuff. And interface types work with JS wasm interface, the wrapper we made, that works in memory, organizes the puts all the things in the right way, calls wasm function, which can work with this state. And also interface types need to get the result, as it can also contain some dynamically allocated things or complex structures. And then we just return the results all the way back, and Fluence JS can pass that service result to Aqua. So that is all the architecture of the Marine.js. And I want to talk about our milestones in it. So we divided the project into several milestones. First, it was just make some proof of concept to run aqua VM in Fluence.js. And now the Fluence.js runs the same aqua VM as the Rust node does using the Marine.js. The next update, which we will announce tomorrow, is running arbitrary pure models in Fluence.js. And it was an interface for it that I showed you. Also, the future work is supporting wasm and some host imports, maybe imports of JavaScript functions that user needs to be able to run. And then the last is full support of multimodal services. So basically, it's the most that JavaScript can have, and it will make JavaScript peer as close to Rust peer as possible. So I think it's really exciting to have these things to have to go through this path and finally have like almost indistinguishable peers for browser and Rust. And that's all. Thank you very much for attention. If you have any questions, please ask.
Very cool. Thank you, Valery. Questions, anybody?
I just, could you please turn the slides, yes, to the module flow, the sequence diagram you had, yes. Just a little technical detail. On the JavaScript side, between Fluence JS and Fluence AppService, I wanted to note that actually the AppService is running in the background. So this call dispatching is happening to either web workers in the browser or worker threads in Node.js. So previously we had performance issues with aqua VM, and we decided to run all wasm stuff in background. So it is also cool that you can run all the services in background without sacrificing the performance of your application inside browser. So no blocking of the UI thread.
In the same diagram, I have a question. Where is the boundary between what's happening on the client's browser on their computer and when the call goes out and actually hits the Fluence node somewhere out in the ether?
All that we have on this diagram is executed on in browser in JavaScript. If the connection lies outside this diagram, when aqua VM executes on some node, the interpreter runs the script, gets the result that shows I need to have results from this service call, this service call, this service call. Then Fluence JS calls these services, gets the results, and returns these results to the Aqua interpreter. This interpreter executes code with these results and when it decides that all the work on this peer is done, it returns the result without call requests. And Fluence JS sends the particle to the next peer that will be executing the script that the next peer that is needed. So everything on this diagram is on your computer.
Cool. Thank you.
Anybody else? Any questions? All right, so I have one question. You went through all the registration processes earlier, and at this point, or at what point can I deploy services with Aqua CLI to a JS node, just like I do to a Rust node?
I think that's more question for Pavel, but right now, as I know, it's not implemented, but it is possible to implement this right now with Marine.js. So Pavel, correct me if I'm wrong.
Sure. Basically, the thing that ties us to where we stand is the lack of multi-module services, because the current, basically the current infrastructure on Rust node is all about blueprints and instantiation of services from these blueprints, and we lack this with single module services. So at the moment, we can only load single wasm files and register them as services, but we are working very hard on implementing the full potential of Marine on JS peer. So in future, we will be able to register services like the same way, for example, using Aqua or Aqua CLI. So it will be possible to, for example, load some wasm modules to IPFS and then create a blueprint from them on, for example, a Node.js peer, and then instantiate the service there. So it would be possible in future.
Cool, but right now I can go ahead.
May I add something? Like the use case for this milestone and like what we will probably do with it is a scenario like the following. Alexei just presented the updates in the registry, and there is a security model in the registry when you need to make some bytes from the structure to sign these bytes. And the logic to make this byte array to provide the signature and hence to check the signature currently is implemented on Rust and is available only on the Rust nodes. So before this, when you were using the registry, you were like compromising security a bit. You were not able to check that the bytes that the relay, the node asks you to sign is like that they correspond to the data that you sent. So probably the first scenario will be like, I want to use registry. I go to the network and say, okay, I want to use it. And inside this script, I will download the module that makes these bytes locally. It will be a pure function. I will deploy it. Maybe I will use the custom API, not the same as we have on the Rust node, but it's not to be used from Aqua CLI or something like that, because JavaScript peers are still not fully featured compared to the Rust nodes. But in these scenarios, it will significantly improve security assumptions that we have and security guarantees.
Okay. Was that it on the updates?
We have Pavel.
Pavel, right?
I wanted to show you the demo time. Okay, I'm taking control of the screen. Okay, so do you see the screen? I mean, the screen sharing.
Yep.
Cool. Let's zoom a little bit, or is it fine? Is the screen size and font size okay? Cool. So what we have here, basically, I wanted to show you how you can create a wasm service using Rust and Marine SDK, and then deploy this service to our JavaScript peers. We have a repo which contains service and implement two scenarios where you can use Fluence JS. One on Node.js platform and one in the browsers. So let's start with the service. Let's spin up a console. Okay, so first let's build the service. The service is pretty simple. It is pretty much a calculator, the one like the old school calculator with the buttons where you press plus and then enter a number, and it calculates the result and stores it in its state somewhere in the memory. So we have like functions which add, subtract, multiply, divide, and read the state. And also we do logging of each operation, and the logic is pretty simple. You provide the number, and the calculator updates its state. Next, we have Node.js and browser-based application. Let's first go to Node. Oh, that's one up. And let's do the installation, and just let's have a quick overview of our code. What we do is pretty much we're starting Fluence JS peer. And here are two lines which are responsible for service registration. After we have built the service, it has been put into this artifacts directory. And here we are referencing this one wasm file. And we are registering it under the ID called calc. So after the peer is started and everything has been registered, we can see the peer ID and the relay ID of the peer. And it's been connected to network thanks to the relay that we picked from Fluence network environment. So let's check if it is working. Let's spin up a second console. And in the repository root, we have demo calculation. This is quite a simple aqua script. Not the aqua script, but aqua file with program written in aqua language. So we're just hopping into the peer, which is serving the our calculation service. This line means that we use the calc service with the ID calc, the same one that we'll be using to register it, and then we perform some operations. To run the aqua file, you can use aqua run command, and to make life a little bit simpler, I've created a bash script for that. So let's try it. The script requires us to input the peer ID and the relay of the peer which is hosting the service. So let's copy them from another terminal. Okay, and it says that the result of our little calculations is 7. If you run it one more time, it starts from 7 and does all these steps and has a different result. And we also see that the process which has been hosting the wasm has all the logs enabled. So it is pretty much these lines, these ones. So we can see that our service was written in Rust, and then we deployed it to Fluence JS, run it inside the node, and have it working. Okay, now let's do the same thing, but inside browser. So let's go with a web example. I'm just to show you that the code is pretty much the same. We're doing the same thing, but we are running it in the browser. Okay, so let us wait for everything to start. And okay, now let's use another terminal. Are we correct? Yes. And we see that the result is 7. So we can also go to the console and look at the web worker tab, and we see that the service executed the same calculations. And just to double check, we can try to run the same calculations on the Node.js service just to make sure that everything is correct. Okay, so we see that there were the computation it did. So here is how it works. This demo, this repository will be available, I think, tomorrow. Please stay tuned for updates. There will be update in the Telegram. I'm pretty sure this is our main source of updates, and we will you will see the update, the announcement for update with all the release versions and links to repositories and docs. Well, I mean, everything you needed to try this out yourself. So thank you. Questions?
Yeah, I do. Do you have an example where you use a part of the service in Rust and part of it on a JS node? So make all the additions on your Node.js and subtraction and division on a Rust node, for example?
Oh, this is going to be quite hard. Do you want like to split the functionality between these two services?
No, but I mean, if you deployed one service on JavaScript and one on the Rust node, Aqua should be able to do whatever, right? You could use
yes,
on one and
that's
on the other.
Yeah, okay, get it. That's totally true. You can deploy this service created from this wasm file to Node, to Rust node, and it will output the same thing. But in order to do that, I have to create first a blueprint and, well, first a module definition, if I remember correctly, then a blueprint, and then I have to deploy it to some node. So I won't be able to do it right now.
Okay, no, but when you
definitely
release it
doable.
tomorrow. Okay, cool. Yeah, with Aqua CLI, it's pretty quick. You don't have to do much. Cool. Anybody else have any questions? Well,
I have one. Is there any limitation in the complexity of the service on the JavaScript side and on the Rust node side? Like what computations they are capable to run and what they are not? Can I run SQLite Redis? Can I do like cryptography in these services?
Okay, so my question would be everything you can do with WebAssembly, you can do on both sides, on JS peers and on Rust peers. So if SQLite And you of course know that we have SQLite compiled to wasm. So if you have your computation compiled to wasm, then no, not just any wasm, but wasm compatible with Marine. So if your computation can be compiled to a wasm file compatible with Marine interface, then you can do it. So if you can, you were talking about cryptography, yes? So if your if this cryptography can be done in Rust and it can be compiled to Marine, then yes, it is possible. Speaking of other limitations, at the moment, we do not support effector modules. They are only supported in Rust node. In order to do this, we have to improve on our wasm bindings. Currently, they are not fully implemented, and even after we will, there will still be some limitations on browser side. Simply because, for example, you cannot run external binaries from browser. But speaking of Node.js, I think it would be totally possible to do everything that we can on Rust node, including effector modules, and for example, external binaries and storing data to files, etc.
Larry.
So I want to add that we are not really limited to Rust code. We use SQLite that is written on C or C++, I don't remember, and we have written interface types adapter ourselves. Like it is a simple script, like the WebAssembly commands, and we embed it into wasm using our Marine tool, and use the SQLite in WebAssembly. It works in JS and it works in Rust nodes. So we are not limited with Rust. We are just limited with access to file system, network, or and so on.
Sounds awesome. Thank you.
So one of the more used binaries, I guess, and modules is the curl service, right? That, it's used in a lot of modules. And so, but in the browser, that's not going to be possible, right?
Yeah, that's not going to be possible, but in future we may be able to pass like XML HTTP request or something into the module instead. It is discussable. It's to be discussed, but that
I like it. I like it. I like it. Good. Okay. Anybody else have any questions? It was pretty awesome. Well, in that case, thank you everybody for participating. Thanks for the great work. Bob and Matt, thanks for taking time, coming and presenting. It was awesome. And I guess we'll all see you in 2 weeks. Same Zoom. Possibly
Thanks,
the same.
Thank you.
Right.
Bye.
Cheers. Bye.
Bye-bye.